Hello friends, so this is the sixth question which we are going to discuss on application of Norton's theorem to electrical circuits. So here we have is the circuit and we have to find the Norton equivalent circuit across the terminals A and B. Okay, so the first part is to find the Norton current. We have to short circuit these two terminals and find the current flowing through it. And the next part is the calculation of equivalent resistance. Okay, so first part, determination of IN. So let us redraw the circuit. So we have 120 volt, then we have 6 ohm, then 3 ohm, then we will short circuit the two terminals, then this, then we have 6 ampere, then we have 2 ohm. Okay. Now here, because these two terminals are short circuited, this 4 ohm resistor, it goes out of the question because the equivalent resistance between these two will be 0 because of this short circuited path. So we can remove this resistor completely. Okay, so now we have to find this current IN flowing through this short circuited path. So we'll be using nodal analysis method. Okay, so let us assume the voltage here is V. So because it is short circuited, the voltage here will also be V. So we'll apply nodal analysis. Let us assign the current directions. This going towards, let us say this current is going downwards. Okay, and this is 6 ampere and this is also going in this direction. So applying nodal analysis at this node V, we will get 120 minus V by 6 flowing towards the node, and 6 ampere is flowing towards the node. These two nodes are the same because of this short circuit. So this current and this current, 6 ampere, they are flowing towards the node. So they are on one side. And then we have V minus ground, that is 0 by 3, this current, and this current, V minus ground divided by 2, V by 2. So now we have to find V. So we can take it out, 120 by 6 minus V by 6 plus 6 is equal to V by 3 plus V by 2. Or we can write it as, this is 120 by 6 plus 6 is equal to V by 2 plus V by 3 plus V by 6. We take this on this side. So now this is 26. Let us take the LCM here. 6, this is 3V plus 2V plus V. Okay, by 6 is equal to 26. Okay, so now V is equal to, this is 6V by 6 is equal to 26. That implies V is equal to 26 volt. This this is 6V, isn't it? 6V by 6 is equal to 26. 6 is got cancelled. V is equal to 26 volt. So we have got V. Now this V here is equal to 26 volt. So this current here, this current will be 26 by 2 ohm. 26 by 2 ohm, which is equal to 13 ampere. So this current is 13 ampere. Okay. Now here 6 ampere is going towards the node. Let us do it here like this. At this node, here we have IN, here we have 6 ampere, and here we have 13 ampere. So here IN plus 6 ampere is equal to 13 ampere. That implies IN is equal to 13 minus 6, which is equal to 7 ampere. Okay, IN is equal to 7 ampere. We have got IN. Now we have to determine RN. Okay, and then we will get the Norton equivalent circuit. So we have got IN. Simple application of KCL here. We determined this current flowing through the 2 ohm resistor, 13 ampere. Then we applied KCL. We got IN plus 6 is equal to 13. So IN is 7 ampere. Okay. So we have got IN is equal to 7 ampere. Now we have to find the Norton equivalent resistance. So for that we have to deactivate the independent sources. Here we have two independent sources, 120 volt voltage source, 6 ampere current source. So voltage source will be short circuited, current source will be open circuited. Okay, this is open circuited. Okay, 6 ohm, 3 ohm, 4 ohm, 2 ohm. This is RN. So here you see, this is short circuited, this is open circuited. Voltage source short circuited, current source open circuited. So here you see 6 ohm and 3 ohm, they are in parallel with respect to each other. The resultant is in series with 2 ohm, and that is in parallel with 4 ohm. So RN here will be 6 parallel 3 plus 2, then the whole combination is in parallel with this 4. So it is 6 into 3 by 9 plus 2. This is 10 parallel 4. So this is 2. Okay, which is 4 parallel 4, which is equal to 16 by 8, which is equal to 2 ohm. So Norton equivalent resistance is equal to 2 ohm. Okay, so we already calculated IN is equal to 7 ampere. Okay, IN was 7 ampere, RN is 2 ohm. So the Norton equivalent circuit will simply be 7 ampere, the Norton current, then the Norton equivalent resistance parallel with it, which is 2 ohm. This is IN and this is RN. Okay, so this is the Norton equivalent circuit. So this is the sixth question related to application of Norton's theorem. So this circuit, its Norton equivalent is this. Okay.